4. P is a point in the interior of a parallelogram ABCD. So that we'll try to prove this right on the given to prove again. So construction, when you look here, you can already see we'll draw a line EF through P, okay, in such a way that all these three lines will be parallel to one another, okay. And then what we also know, the opposite sides of a parallelogram are equal, right? So when you look at the parallelogram, these two lines are equal to one another. But now we've already said that what these three lines are parallel to one another, okay, which means all these three lines are also equal to one another. All right, now from there we'll get two parallelograms here. This is a first parallelogram, and even down here this will be another parallelogram, okay. AEFB is a parallelogram, same thing. EDCF will also be another parallelogram. Clear? All right, so that's what I'm just trying to write here, okay. Therefore AEFB and EDCF are parallelograms, right? Once again, the theorem: if a triangle and a parallelogram are on the same base and between the same parallel, then area of triangle is half times the area of the parallelogram, right? So the first triangle that we'll be taking is once again this upper region here. All right, can you see this triangle here? You can see, right? So they share the same base, and also they have the same altitude here, right? Which means area of triangle APB should be equal to half times the area of the parallelogram AEFB. Okay, now the second time we'll take the lower one again. So if you look, can you see a triangle and a parallelogram again? We can see, right? This is the triangle here, you can already see, and then this is the parallelogram, right? Now do they share the same base and the same height of the parallelogram? They share, right? Base will be this, and then the altitude is this. So they have the same base and the same parallels, okay, are between the same parallel. So that is what I've written it down here. Clear? Now when we add this equation 1 and 2, like our previous question that we did, right? Left hand side will add together, right hand side will add together. All right, so area of APP plus area of BCD, okay, equals half times the area of AEFB plus half times the area of EDCF. So once again we'll be taking half common here, okay. Then when you add these two, what do we get? AEFB, right? So AEFB is this, and then area of EDCF is this, right? So do I get ABCD? We get, all right. So we can see here area of ABB plus area of BCD equals half times the area of ABCD, which is our first proof. Okay, now we'll try to prove the second part again. Here again, the second time we'll draw this again, okay, GH going through P in such a way that all these three lines are parallel. And again, if they're parallel, because we know the opposite sides of a parallelogram are equal, right? We know that AD is equal to BC, right? In other words, all these three lines also should be equal to one another, and then from there we'll get two parallelograms again, right? The first parallelogram will be let's go with this parallelogram, right? And then the second parallelogram will be this. Clear? We'll get two more parallelograms like in the first proof. All right, so this is what we have written it down. So here we'll skip one step, okay. Here we did equation 1 and 2, right? But here, because we already know direct, so I'm just going to write straight away, okay. We'll get that what once again, if you look here, you will see what, consider this region first, okay. Do you see a triangle and a parallelogram, right? They share the same base, and they also have the same height. And if you consider this side again, you will see there's a triangle and another parallelogram here, right? So when you look there again, they share the same base. The base now will be this, and also they share the same height again, right? So we're going to skip one step and we're just going to write down directly, okay, that area of this triangle, right, plus this area of this triangle should give me half times the area of triangle ABCD. Clear? Now if you look at equation 3, this is what we have, right, from the previous. And now if you look at this equation 4, can you see that the right hand side are equal? Half the area of ABCD, and then if you look here again, half the area of ABCD, which means will their left hand side be equal? This and then this, will the left hand side be equal? It should be equal, okay. So there is how we'll get our second proof.